Dear students, we are heading with the series of numericals which is based on the electrostatics. Now, if we go through the numericals and if we go through the problems which is given, so sometimes we come to understand that is a combination of some say electrostatics, say kinematics, and a combination of that. Now, similar question which we have here, it is 2-point charges Q1, that is of minus 2 microcoulomb, which is placed here, and Q2 4 microcoulomb are lying on the y-axis. They are equidistant from the point A, which is on the x-axis. A small particle of charge Q is placed here, Q0, which is of having value 4 microcoulomb, and a mass of 6 gram is placed at the point A. When it is released, what is the acceleration in meter per second? That we have to calculate. Now, first of all, what we have to do? We have to need to know about the force. Now, here we will be using Coulomb's law. There will be one force which is acting in this direction, that is attractive force. Why it is attractive? Because it is of minus nature and it is of positive, so it will be attracting towards this. So we have taken this F1 which is acting in this direction, which is making an angle 30 degree with this x-axis. Similarly, a force of which will be acting, that will be F2, which we have taken in this direction. Why it is in this direction? Because it is a force of repulsion. A positive charge and another positive charge, there will be a force of repulsion which will be acting in this direction. Okay, so we have got these two forces. First of all, we will determine the forces, and then we will go with the force is equal to mass into acceleration. So first of all, we need to know about the forces by using the Coulomb's law. Now here we can resolve these two forces. If one force acting in this direction, say it is F1, and then it is F2, which is making an angle of 30 degree. So F1 cos 30 is in this, and F2 sin 30, F1 sin 30 is in this direction. Similarly, a force which is acting in this direction, that is F2, which is making an angle 30 degree with the x-axis. So one component is F2 cos 30 and another component is F2 sin 30. Both will be in the same direction. So in F, we can say it is Fy, which will be given by F1 sin 30 plus F2 sin 30. And similarly, Fx, which is acting in this direction, so it is F2 cos 30 minus F1 cos 30. So these two forces which is acting in this direction, and their resultant will be there. With the help of their resultant, we will determine the force. So first of all, we need to know about F1 and F2. So we'll go with the Coulomb's law. F is equal to 9 into 10 raised to the power 9 Q1 Q2 upon R square. Now the force which is acting because of this, that we have taken F1. So F1 will be given by 9 into 10 raised to the power 9. Q1 is 2 into 10 raised to the power minus 6. It is of negative nature. So this will be the force of attraction. And another, it is 4 into 10 raised to the power minus 6. We can put it here, 2 microcoulomb. Divided by 1 square, the distance is 1 meter. So 4 to the side and 9, 72, and this 10 raised to the power 9 minus 12. So it will give 72 into 10 raised to the power minus 3, ultimately 7.2 into 10 raised to the power minus 4 Newton, the force which is F1. Okay, now we will calculate it for F2. So F2 means this force of attraction, a force of repulsion which is acting in this direction. It is a 4 microcoulomb. So again using the Coulombic force, it is 4 into 10 raised to the power minus 6, and another one is 4 into 10 raised to the power minus 6. The distance is same, 1 square. So 9, 4 4s are 16 into 10 raised to the power 9 minus 12. So we are having 144 into 10 raised to the power minus 3. So it is 40.4 into 10 raised to the power minus 4 Newton. This is the force which we have, F2. Once we have got this, we can have this expression here. And final the force which is acting, that we can take Fx I cap plus Fy j cap. So first of all we will calculate Fx. So Fx will be given by cos 30 means root 3 by 2. F2 we have got this 14.4 into 10 raised to the power minus 4 into the value of cos 30, that is root 3 by 2, minus F1 that we know 7.2 into 10 raised to the power minus 4 into, again it is root 3 by 2. So if we go through this, it is 14.4 minus 7.2, because these values are fixed. So it is 7.2 into 10 raised 7.2 into root 3 upon 2 into 10 raised to the power minus 4. It is the value of Fx, means it is 3.6 root 3 into 10 raised to the power minus 4 Newton. The x component. Now if we go with the Fy will be, it is F1. We know that the value of F1, that is 7.2 into 10 raised to the power minus 4. The value of sin 30 will be 1 by 2 plus 14.4 and thus the value of F2 into 10 raised to the power minus 4 into 1 by 2. So 14.2 and 17.2, it will give 19.6 upon 2 into this 10 raised to the power minus 4. So finally we have got this 9.8 into 10 raised to the power minus 4 Newton. This is the component of y. Now we'll substitute in this. We are having this relation. It is 3.6 root 3 I cap into I cap plus 9.8 j cap 10 raised to the power minus 4, which we have taken it outside. This is the force which is the resultant force, means it is a combination of these two, vertical x axis component and y axis component, both the forces, which is. So finally if we go with this, F is equal to, we have got 3.6 root 3 I plus 9.8 into 10 raised to the power minus 4. Now if finally we can have Fx, this force divided by mass will give the acceleration. So if we substitute it here with dividing it by this mass which is given to us 6 gram. So I am writing it here, 3.6 root 3 plus 9.8, here we can take I cap, j cap and into 10 raised to the power minus 4 divided by 6 and 10 raised to the power minus 3. So here we are having this 3.6 root 3 I cap plus 9.8 j cap. Now this 10.4 and this 10.3. So it is, in denominator we can take it 60. This is the acceleration which we have. Now if we simply finalize it, so it is 1 upon 30, 1.8 root 3 I cap plus this 4.9 j cap, which is the acceleration which we are having. This is the acceleration which we have. I am putting it in block divided by 60. I am writing it here. So here we have got this 1 upon 30, 1.8 root 3 plus 4.9 j k. 1 upon 30, 1.8 root 3 ik plus 4.9 jk meter per second square. So here we have got the acceleration which is asked here, and by applying the Coulomb's law and finally Newton's second law, that is F is equals to m into a, mass into acceleration, we have got the final answer. That is acceleration 1 upon 30, 1.8 root 3 ik plus 4.9 jk meter per second square. So in this manner we can solve the numericals. Watch it continuously. We are putting more videos on the channel. You can suggest others to subscribe.